Hi, good morning, everybody. Thank you for joining me this morning or afternoon, depending on where you are, in the presentation that I'll plan on going over and updating, actually, on some of the reference material from the previous webinar that I have given regarding the design of steel moment frames. So here's a little bit of overview on the information that I plan to cover. Give you folks a little bit about the background of steel moment frame design. I think that it is a lot of good information that we can learn from when we look back on past events that we've been able to study and learn about the techniques and improvements that have been made from lessons learned from earthquake events. I'll talk about the pre-qualification testing regarding special moment frame and some of the steel moment frame design reference standard, and then go over briefly on the different various frame connection and some of the comparison of the available pre-qualified connections, and then talk about the highlight on some of the specific conditions for these pre-qualified connections. Then dedicate some slides here on going over the ordinary moment frames and provide a quick design example here on how we look at the design of the ordinary moment frame when we have different systems. And then lastly, some of the slides that I've updated to talk about some moment frame design considerations. Some of these come from a lot of the questions and I suppose frequent questions and answers that have come up from my experience of discussions on design consideration with design engineers. So going back here, I'm talking about the brief history of the moment frames. These connections here kind of evolved over time, first starting off by using actual built-up sections, angles, and plates to actually form these eye sections. And so they actually performed relatively well from what we were able to learn from the 1906 San Francisco earthquake. Partly, I would say, it was the fact that a lot of these connections, there were a lot of these connections kind of spread out throughout the building, which is a little bit different than the common practice that we see today. And so it lends itself to, I would say, a lot of redundancy on spreading out, helping us spread out those demand loads. And so from the period between 1960 and 1999, the design from the bolted connection kind of went away, and actually as welding technology and capability improved for fabrication on site, the design and the practice tend to be more towards fabricating by welding the connection on the job site. With the advent of computers, designers were, looking to concentrate these moment frames to reduce the labor and therefore the cost of constructing these steel buildings, where the demand loads were essentially concentrated towards a few dedicated bays that would be designed to carry and transmit the seismic lateral force or wind load. And so up to, I would say, 1994, information regarding the connections were relatively limited. we had the 1971 San Fernando earthquake here that is probably the one major event that started off or kicked off this notion of, earthquake design, and building codes quickly evolved from that to consider many different aspects of earthquake design that we actually see now in the building codes today.